This is 4.2, solving rational equations. So far we have simplified rational equations where we just factored everything and canceled. We multiplied and divided rational equations, which wasn't really that much different than simplifying them. Then we added and subtracted them, where you had to get a common denominator, put them together through addition or subtraction. Today, we're actually going to solve equations though. So when we get to the end of this is going to say x equals whatever x equals. All right. We're going to kind of divide this up into two ways, but they're really kind of the same thing. These first two, we're going to do one way, and then the other ones we'll do the other way, which again, they're both kind of the same. So number one and number two here, both of these are proportions. And proportions just means that you have a fraction equaling another fraction. And so anytime you got a proportion with, that is with dealing with x's, algebra stuff, we can solve this by just cross multiplying. So I'm going to multiply these two together, multiply these two together. So this is 20 times x minus 2 equals 5 times 3x minus 5. And then it's just regular old algebra stuff. 20x minus 40 equals 15x minus 25. Subtract 15x on both sides, that'll give me 5x over here. Add 40 on both sides, that gives me 15 over there. X equals 3. Now, you've heard me mention before, and it's actually on the packet of notes that goes with this, extraneous solutions. And so an extraneous solution means that we did all the algebra stuff correctly. We didn't mess anything up. But then when we get to the end, sometimes you get an answer that doesn't actually work in the equation. And when we say it doesn't actually work, what we mean is that it causes some part of the equation, so one of these fractions in the original equation, to be undefined. So you don't have to do a big long plugging it back in and making sure they actually equal each other. That's not a terrible thing to do. But when you're just checking for extraneous solutions, all you really need to do is take a quick glance at these denominators and make sure that your answer wouldn't make either of those denominators equal 0. And you can see I could put 3 in right there and that would not be 0. I could put 3 in right there and that would not be 0. That means that 3 is okay. 3 is the answer. All right, same thing with number 2. Number 2 is still a proportion. This is really 2 over 1. You could put it over 1 if that made you feel better, but you don't need to. I'm going to do the same thing here where I cross multiply. So this is 2 times x minus 3 equals 1 times x plus 2. And so this is 2x minus 6 equals x plus 2. Subtract the x over, add the 6 over, x equals 8. Again, do a quick glance. Make sure that whatever you said the answer was doesn't make anything undefined. It doesn't, so we're okay. X equals 8 is the answer, and that's it. All right. When you get to number 3, you can see they're a little different. We can't just cross multiply anymore. So you remember I told you there were 2 ways of doing it. We did it the cross multiplying way, but now you got more than 2 terms here. It's not just a fraction equaling another fraction. You got several fractions throughout the equation, or at least more than 2. So what we're going to do now is we want to make this so that there aren't any fractions. Because if it was just a regular old equation that didn't have any fractions, well, that wouldn't be any problem. So it is perfectly legal to multiply an equation by whatever you want to multiply it by, as long as you multiply every single term in it by whatever that is. And so what we want to do here is we want to multiply our equation by something that would make these denominators cancel. And again, it's a perfectly legal move as long as I multiply the same thing to every term. So when I'm trying to decide what it is that I want to multiply, what I'm going to do is look at these denominators, and I want the least common multiple, because the least common multiple would be something that's big enough to make them all cancel. It's the same strategy that you used when you were finding a common denominator. So I'm going to look at these three denominators. I've got an x, a 3, and an x. The least common multiple between x and 3 and x would be 3x. If you were putting three fractions together and you're trying to get a common denominator, and those were the three denominators, your common denominator would be 3x. So like I said, it's the same sort of strategy. Whatever you decide that least common multiple is, that's the thing that we're going to multiply to every term. So in this case, my least common multiple is 3x. I'm going to go in here and I'm literally going to multiply every single term by 3x. And when you multiply, a number or something to a fraction, all you're really doing is sticking it into the numerator. So I'm just going in there and putting a 3x in all those numerators. Again, it might look crazy, but it's a perfectly legal move as long as I do it to every single term. So, that didn't really seem to help. As a matter of fact, we just made it uglier. But if you look at what's about to happen now, that 3x that I put in the numerators of all those fractions is going to make all those denominators cancel. So like, look at this first term right here. That x would cancel that x, and I would just be left with 8 times 3. In this second term, that 3 would cancel that 3, and I would just be left with 11 times x. And over here, that x and that x would cancel. I would be left with negative 14 times 3. And now it's just regular old algebra stuff. This is 24 plus 11x equals negative 42. Minus 24 on both sides. That would give me negative 66. X is negative 6. Quick check, make sure negative 6 is not going to make anything undefined. It doesn't, so we are good. Same thing here, almost the exact same thing. I've got a 2, I've got an x, that's really a 1 in the denominator there, and I've got this x. My LCM, my least common multiple for this one would be 2x. And so I put a 2x in every single numerator, just like that. And again, all you're going to do now is cancel whatever got canceled and then write whatever was left. So the 2's get canceled. I'm left with 3x right there. Here, the x's got canceled. I'm left with 1 times 2. Here, nothing canceled, but that's okay because it didn't have a denominator anyway. It's left with 2x. And then over here, these x's canceled. I'm left with 4 times 2, which is 8. And now I can just subtract 2x on both sides. That'll give me x. Subtract 2 on both sides. That'll give me 6. X equals 6 is my answer. We need to check and make sure it's not extraneous. It doesn't make any of those denominators equal 0, so it is good. And that's it. All right, next ones. You can see they're getting a little bigger, getting a little uglier as we go, but the process is still the same. All I really want to do is multiply all of these terms by something that will make all of those denominators cancel. This time I've got an x squared, I've got an x, and I've got a 2x. We're trying to think of the least common thing, the least common multiple, the smallest thing, in other words, that all three of those would evenly divide into. So just like we did on the last two, this time I've got an x squared, an x, and a 2x. That means my LCM would be 2x squared. And so again, I literally go in here and stick a 2x squared into all of these numerators. And again, it's kind of ugly at first, but after we cancel some stuff, it'll look a lot nicer. So in this first term, the x squareds cancel, and I'm left with 2 times x squared minus x minus 6. I'm going to bring that minus sign down. In the next term, this x takes out one of those x's, and so I've got 2x up there times 2x plus 12. Then in that last one, the 2's cancel. That x again takes out one of those x's, so there's just an x left there now. So that's x times x minus 6. And it's just regular old algebra at this point. So it's 2x squared minus 2x minus 12 minus 4x squared minus 24x equals x squared minus 6x. So I'm going to group some like terms here. 2x squared minus 4x squared is negative 2x squared. Negative 2x minus 24x is negative 26x minus 12. And then obviously we're dealing with a quadratic here. And so if I'm going to solve it, I need to make it equal 0. You know, regardless of the method I'm going to use to solve it, it needs to equal 0. And so, you know, it's nice if that x squared term is positive. So instead of bringing this stuff over here, I'm actually going to take all of these things, all these terms, and put them over there. So I'm going to add 2x squared. I'm going to add 26x. I'm going to add 12. So when I do that, that would leave me with a 0 on this side. X squared plus 2x squared would be 3x squared. Add 26x over to that, I would have positive 20x. Add 12 over, I would have positive 12. All right, so now I got to factor this. It's, you know, one of those that's kind of annoying to factor. I'm going to kind of go through this quickly. You know, this is something that you should be an expert on already. Just like with the last unit and with some units in the future, the stuff that we're doing isn't really that difficult. It's the factoring that messes people up. So if you're not a factoring expert, then you need to become one. That's a Math 1 skill. So by the time you get here, you should be, you know, just smoking through this. In this one, I got to multiply the 3 and the 12. By the way, there are lots of ways that you can factor. It doesn't matter to me how you do it. You know, this is the way that most of you do it. So that's why I do it this way. But if you have your own way that you learned from your Math 1 teacher or from some other teacher, that's totally fine with me, as long as it's right. All right, so I'm going to rewrite this thing as 3x squared plus 2x plus 18x plus 12. Group it like that. Here I can take out an x, that would leave me with 3x plus 2. Over here I can take out a 6, that would leave me with 3x plus 2. That's a good thing, so 0 equals x plus 6, 3x plus 2, which means that x equals negative 6, negative 2/3. Again, just do a quick check, make sure none of those make any of those denominators equal 0. They don't, so that's okay, that's good. All right, I'm gonna make a little line here so I don't run into myself. Okay, so number 6 presents sort of a new problem that we haven't seen yet. You can't really determine what the least common multiple is unless all of your denominators are completely factored. It hasn't mattered on any of the other ones, they weren't factorable. But this one actually has a denominator that is, and we need to do that first. So 4x squared minus 1 will actually factor to be 2x plus 1, 2x minus 1. It's the difference of squares. Then when you're deciding what your least common multiple is, you got a 2x minus 1, a 2x plus 1, and then this one is a 2x plus 1, 2x minus 1. So the least common multiple is 2x plus 1, 2x minus 1, which means I got to go in here and give every one of these numerators 2x plus 1, 2x minus 1, 2x plus 1, 2x minus 1, 2x plus 1, 2x minus 1. And so then, you know, we made it way uglier than it was, but now it's about to get a lot nicer. Here the 2x minus 1's cancel. That leaves you with x times 2x plus 1 minus. Here the 2x plus 1's cancel. So that's 2 times 2x minus 1 equals, well here everything canceled. So we're just left with x squared plus 20. Now we got an equation with no fractions, that was our goal. And so just regular old algebra stuff. I got 2x squared. I'm going to go ahead and subtract that x squared over, so that's x squared. X minus 4x is negative 3x. 2 minus 20 is negative 18. This one factors a lot easier than the last one. This will be x plus 3, x minus 6. And so my answers are negative 3 and positive 6. Again, check. Make sure that none of those denominators would be made 0 by plugging that number in for x or that number in for x. They're both good. Neither one are extraneous. That's it. Okay, last one. Same dilemma that we had on the last one. All my denominators aren't completely factored, but you know, we can fix that pretty easily. That first one is the difference of squares. Factors would be x plus 4, x minus 4. And again, you know, looking at my three denominators that I have here, it's pretty obvious that my least common multiple is going to be x plus 4, x minus 4. So, x plus 4, x minus 4, x plus 4, x minus 4, x plus 4, x minus 4. And so what a lot of you really smart folk out there, what you've probably already figured out is that, you know, this is really kind of a waste. It just makes it junky and it really doesn't help anything. You know, this next line, the only thing that's really happening here is the existing numerator goes, and then whatever part of the LCM that denominator was missing goes with it as well. So like for instance, you know, x plus 4 cancels x plus 4 and x minus 4 cancels x minus 4. So I would just have the 6x squared there. So in other words, since that denominator wasn't missing anything, I didn't put anything with the 6x squared. Same thing here. The x plus 4s would cancel, which means that would be minus 3x times x minus 4. Over here, the x minus 4s cancel, so that would be 4 times x plus 4. So my point is, you can actually, you know, just go straight to this step. As long as you can keep it all straight in your head. There's no reason to, you know, to write all that out, but that is what's actually going on. You know, you're multiplying all those terms by the same thing, and it allows us to do this. But, you know, after you've done a few of them, you can see that all you're doing is putting the numerator with whatever part of the LCM the denominator was missing. So I don't have a problem if you go straight to this line right here, again, as long as you get it right. All right, so do a little bit of work here. A little distributive property. 6x squared minus 3x squared is 3x squared. I'm gonna go ahead and bring this 4x over. That's gonna make that an 8x. Bring the 16 over, makes it minus 16 equals 0. 3 times negative 16 is negative 48. Numbers that are multiplied to be negative 48 and add to be positive 8 would be negative 4 and 12. So this is 3x squared minus 4x plus 12x minus 16 equals 0. So we group it. So this thing factors to be x plus 4, 3x minus 4. And so x equals negative 4 and positive 4/3. Again, take your answers that you come up with, do a quick check. Now, if you probably already see this is the first time this has come up. If I try to plug negative 4 in for x, it's going to make that denominator equal 0 and that denominator equals 0. And it only has to make one of them equal 0 to make it no good. So x equals negative 4 is actually an extraneous solution, which means it's not a solution. Now, I don't care if you remember the word extraneous or if you can spell extraneous or cannot spell extraneous, but you need to indicate in some way on your work that negative 4 is not an answer. And so my answer to this equation is just 4/3. It's just x equals 4/3. Now those are pretty simple ones. There is a homework that goes with this that's on Canvas that you can print out and you can do. Remember, nothing is required. I'm just trying to sort of stay in contact with all of you, and I don't really know what things are going to look like when we do go back to normal. I mean, so like I said, whatever we're doing right now that's new, we're going to revisit it again once we get green lighted for like actually teaching new material. We haven't gotten that green light yet. So this is just stuff to sort of keep you practicing, keep you sharp. And then, like I said, when we do get back to a regular schedule, we'll revisit this again. It'll probably be a little tougher. I kind of intentionally chose easy ones. But anyway, give it a try. If you get a chance to, please feel free to reach out to me and let me know what kind of questions you have or whatever. All right, that's it.